Now that we've understood how scan right works, let's now go ahead and repeat this process of reverse engineering, but this time with scan left. As before, let's plunge into a demo to first get a sense of how this function is invoked and what the return value looks like. Invoking scan left is virtually identical to invoking scan right. Scan left also is a function which has two parameter groups. Exactly like scan right, it returns a list. The only difference is, of course, in the contents of the list returned. Exactly as in the case of scan right, the rightmost parameter group has a function object. As before, we will continue with our function object specifying the difference of two operands. Once again, this is the minus sign. That's the right parameter group. The left parameter group is again an initial value. The way in which this initial value will be used differs in scan left versus scan right. What's also different is the associativity of the function object. Scan right, that function object was right associative. In scan left, the function object will be left associative. How does this translate into the calculation of the output? It just means that the initial value starts off on the left of the input list rather than on the right. That's really the only difference. Let's understand the mechanics. As before, let's keep in mind three data structures: the initial value, the input list on which the method was being invoked, and the result list, which has got to be constructed. As in the case of scan right, once again, the first value in the result list is merely the input value. The only difference is that now the initial value is popped in on the extreme left rather than on the extreme right. Now the function object will be applied pairwise. As before, function object will always operate on the next unconsumed value from the initial list as well as on the last value added to the result list. But the difference now is in the ordering of the operands. Now, because the function object is treated left associatively, the operand on the left will be 0 and the operand on the right will be 10. And that means 0 minus 10 gives an answer of minus 10, which is then popped back into the result data structure. Now our result data structure has two values, 0 and minus 10, and the rinse and repeat can now begin. Scan left continues rolling towards the right. Next up is minus 10, minus 20, which yields minus 30. Minus 30, minus 30 yields minus 60. The process continues until we reach the end of the list. Once you've understood scan right, all you really need to keep in mind to make sense of scan left is that the initial value starts on the left of the input list and the function object is applied left associatively. We keep going and we get a list which exactly matches the list that we saw in Scala. And once again, we have successfully reverse engineered the scan left operation in Scala.